What's up, Raiders? So I just want to go over a problem with you that's going to be based off of your knowledge of angle pairs, where you're going to have a diagram like this, where you have a bunch of different individual angles, and based on what you understand about vertical angles and linear pairs, if you are given a few measurements, you can figure out what the other angle measurements are. So let's say in this diagram, you're given the fact that the measure of angle 1 equals 40 degrees. So this one right here is 40 degrees. So we can actually label that one right now, 40 degrees. And then let's say you're also told that the measure of angle 8 is 130 degrees. And you're also told that the measure of angle 9 is 80 degrees. So we'll label those on our diagram. The measure of angle 8 is 130 degrees. And then the measure of angle 9 is 80 degrees. So we can figure out all these other angle measurements based on what we know about angle pairs, specifically vertical angles and linear pairs. So let's just go one at a time. So if we look at angle 1 and angle 3 here, anytime you have an intersection of two line segments or rays, the angles that are across from each other are going to be vertical angles. And vertical angles are always congruent, meaning they have the same measurement. So the measure of angle 1 equals the measure of angle 3 because they're vertical angles. Because they're vertical angles, so that tells us then that the measure of angle 3 is also 40 degrees. So we can label that one. And we can put the tick marks to show that those angles are congruent. Now, take a look at angle 2 and angle 3. These are not vertical angles, but they are two angles that are formed by the intersection of two line segments or rays. But notice a difference here. With the vertical angles, they shared this vertex. This point right here, that intersection point, that was the vertex for angle 1, and at the same time that was the vertex for angle 3, but they didn't share any sides. If you look at angles 2 and 3, they share a vertex. Here's the vertex for angle 2, and at the same time that point is the vertex for angle 3, but they also share this side. This side here is part of angle 2, and at the same time it's part of angle 3. And collectively, when you put together angle 2 and angle 3, besides sharing a vertex and a side, collectively, they also make a straight line or segment. And we know, if you think about a right angle like the capital L is 90 degrees, well, if we put that back to back with another 90 degree angle, putting them together, they make a straight segment there. So collectively, anytime you have a straight line or segment, it's going to be 180 degrees. So going back to here, angle 2 and angle 3 added together have to add up to 180 degrees. So the measure of angle 2 and add to that the measure of angle 3, those have to add up to 180 degrees. And we know already the measure of angle 3 is 40 degrees. So now we can use that information right here. The measure of angle 2, which we don't know yet, we're going to figure that out, plus the measure of angle 3, which we do know what it is. It's 40 degrees because it's the vertical angle with angle 1, so they have to be the same. So those two angle measurements added together have to equal 180. Now this becomes an algebra problem with one step to solve it. We want to get the measure of angle 2, so to isolate this, to get it all by itself, undo whatever's happening to it. So the opposite of adding 40 degrees, subtract 40 degrees from both sides of the equation. So we know that the measure of angle 2 equals 140 degrees. So far we know we figured out the measure of angle 3 by virtue of being a vertical angle with angle 1. It's got to be congruent to it, have the same measurement, that's 40 degrees. And then angles 2 and 3 are a linear pair. They have to add up to 180. So if this one's 40, this one's 140. Now, if you look at this last little junction here, this intersection here, out of these four individual angles, that only leaves us with getting angle 4. Well, angle 2 and angle 4 are vertical angles across from each other anytime you have an intersection. And vertical angles are always congruent. They have the same measurement. So the measure of angle 4 has to be 140 degrees. So in terms of documenting that, the measure of angle 2 equals the measure of angle 4 because they're vertical angles. So that means the measure of angle 4 is 140 degrees. So we've taken care of now this intersection here, that four individual angles. Now let's go over here where we have another intersection, four more individual angles. And it's really going to be the same process that we just applied for the other intersection forming four angles. So angles 5, 6, 7, and 8. Well, if we look at angles 8 and 6, these are vertical angles, so they have to be congruent with each other. So if angle 8 is 130 degrees, angle 6 is 130 degrees. So we can document that. The measure of angle 8 equals the measure of angle 6 because they're vertical angles. So that leads us to the fact that the measure of angle 6 is also 130 degrees. Coming back to our diagram here, if you look at angles 5 and 6, they're a linear pair. They have to add up to 180. And also you could do it this way. Angles 6 and 7 are also a linear pair. They have to add up to 180. But let's just focus on angles 5 and 6. I think visually that makes a little more sense just because we're used to reading things on the horizontal plane. So these two angles here, they share this vertex. This is the vertex for angle 5 at the same time as the vertex for angle 6. And they share this side. This side here is part of angle 5, and it's also part of angle 6. And we put them together collectively, they make this straight segment here. And any straight segment has to add up to 180 degrees. So that allows us to create this equation. The measure of angle 5 plus the measure of angle 6 equals 180 degrees. Well, the measure of angle 6, we know what that one is, 130 degrees. So we can substitute that right here. The measure of angle 5, which we don't know, plus this 130 degree angle that we do know, collectively they add up to 180. So to figure out what the measure of angle 5 is, subtract 130 from both sides. And we see that the measure of angle 5 equals 50 degrees. So we can put that in our diagram. And then now, angles 5 and 7, those are vertical angles, and vertical angles are congruent. They have the same measurement. So if angle 5 is 7 degrees, then the measure of angle 7 is 50 degrees. So that's taking care of this intersection of four angles. Now we just have this grouping of four angles here. Same concepts apply. Angles 9 and 11 are vertical angles. They're going to be congruent to each other. The measurements are the same. So if the measure of angle 9 is 80 degrees, then the measure of angle 11 is 80 degrees. And then now if we look here, angles 10 and 11, that's a linear pair of angles. They share this vertex. They share this side. And when you put them together, collectively they make this straight segment. So from here all the way over there has got to be 180 degrees. So now that allows us to create an equation here. The measure of angle 10 plus the measure of angle 11, those two angles together have to add up to 180 degrees. And we know what the measure of angle 11 is. We know that the measure of angle 11 is 80 degrees. So we can substitute that in. The measure of angle 10 plus the measure of angle 11, which is 80 degrees, equals 180 degrees. Subtract 80 from both sides. So we get that the measure of angle 10 equals 100 degrees. So this is 100 degrees. And then finally, angle 10 and angle 12, they're vertical angles, so that means they're congruent. Their measurements will be equal. So if the measure of angle 10 is 100 degrees, then the measure of angle 12 is 100 degrees. So hopefully you see how just by applying your understanding of vertical angles in linear pairs, with vertical angles having the same measurements as each other, and linear pairs adding up to 180, being supplementary angles, that if you know some select individual angle measurements, you can figure out a bunch of others. So if you have any questions, like always, you can contact me on the Remind app, or if you're working on individual problems in OdysseyWare, you can send me a question on the Help tab. Take it easy, Raiders.